Now in this video, we want to talk about the inverse of a function. So if we are given a certain function, okay, which will transform elements from the domain into elements in the range set, then the inverse of that function will be doing something in the opposite direction. Good. So the definition of inverse of a function goes this way. But before then, if you've not subscribed to my channel, you go ahead and subscribe to my channel, alright? Turn on notifications, and then you stay alert as you get interesting videos from us. Good. But before I go into the definition, let me visualize a little bit for you when we talk about a function. Let's say these are the input, right? You input something into a function, and then you get the output called y. That is to say, when x comes and is acted upon by the function f, it will transform it into a value y. So this is the input, and this is the output for the input x. Good. So this gives us this equation that f of x is equal to y. Right. That is from the definition of functions. Okay, good. And now, the inverse of a function will be the one that opposes the direction of the effect of this rule. That tells us that the inverse of a function will now move this in the opposite direction. It will now be taking y into x, right? To now be transforming from y to x. So if f takes x to y, then f inverse takes from y to x. If we want to look at the function as a mapping, right, of which they are very, very similar, then we'll be talking about x here, and then f to be the rule, right? Then y here as a result. So f takes every element in here in this first set called the domain, into the second set called the range. But there is another force here called f inverse, a function here called the inverse of that one, that will be taking every element in the range set to the domain. So that means that the domain of this function will be this, while the range of f inverse is this part. But the domain of f is this one, while the range is this part. It's all about where the functions are being defined. Good. Now, for inverse of a function, we will need the function to be a one-to-one function in order for the function to have a unique inverse. Great. Anyway, the explanation of that is going to be deeper into the study of functions. But for now, let me pause here and give you the definition of a function. Then, the definition of the inverse of a function, and then we'll look at how to find the inverse of functions. Good. So the definition, that is definition, right? What we mean by a one-to-one function is a function that when you give it a particular input, it produces an output. Now, there are no two inputs that will give you a particular output. That kind of function is called a one-to-one function. But take it again. If you have, let's say, 5 possible inputs of a certain function, right? Then a function is said to be one-to-one if each of these have a unique image, right? There is no point where two different inputs will give you one particular result. Two different inputs will give you one particular result. If you're talking about the squared function, x squared. If you input -2, and -2 squared, you're going to have 4. If you input -2 in place of x, if you input 2, you also have 4. That means two different inputs, -2 and 2, are giving you a single output. But a one-to-one function contradicts this, alright? Good, so you should get a better picture of what I'm talking about. So let f be a one-to-one function, alright? Such that good. Okay, this is what we've got. We say that the definition of inverse of a function, that we define f to be a one-to-one function, right? Such that x is the domain. So f is a one-to-one function that has its domain to be x, and then has its range to be y, right? So you note the range and the domain, they are set, so denoted with the uppercase of letter x and y. Now, this is the inverse of the function f, then the f inverse, that is the inverse of that function, has domain y and the range x. So the other one was having domain x and range y. This one is opposing that. Great. So this tells us that f inverse of y is going to be x, if and only if f of x gave us y for all y in the second set. So if we talk about, let's look at this diagram again. So this is the domain, while this is the range. Okay, you can call it codomain in general. All right, so f move from here to here. So for all x in the domain x, then if f acts on that, that will give us y for all y in the range set y. But f inverse has its domain to be y, that means it will now be acting on this one and transforms it into this one, right? So you can get the picture of the inverse of a function, but it has to be a one-to-one function. Since it's only one-to-one function, we have unique inverses. All right, thanks for watching, and please subscribe to my channel.